Question 17 asks us if the table below is a proportional relationship or a non-proportional. So remember, for something to be proportional has to do with three things. First of all, it must follow the equation of y equals kx. And in this case, that means that we have to have some constant of variation or a common difference. That k term has to be there. And that k term cannot be 0. And lastly, it must pass through 0, 0. Or if our x, our number of cartons, is 0, the cost would also have to be 0. So let's go step by step. First, as we progress in our cost, our y values, do we have a common difference? The top, you can see, we're going up by 1 each time, so that's good. The bottoms, we have 2.25 to 4.50, that's an increase of $2.25. From 4.50 to 6.75, again, $2.25. And you check all of them, and in this case, they all work out. And lastly, yep. So we have a common difference throughout the entirety of the table, which is very important that we check every single one. So, do we have a constant? Yes. Is it 0? No, so that's good. Lastly, will it pass through 0, 0? So if we go back and make a new category here, if we buy 0 cartons, we follow the same pattern back. If we subtract 2.25 instead of adding, well, 2.25 minus 2.25 is 0, so that checks out as well. So yes, indeed, this is a proportional relationship. And again, the hint is if you actually made all these fractions, would they be equivalent fractions? So you have 1 over 2.25. Is that equal to 2 over 450? And that actually does work out. Obviously, you're multiplying the top by 2 and the bottom by 2, so those are equivalent fractions.